Okay, this is problem number 14 on the trigonometry practice test. I want you to enter this problem with the mindset of this one's just going to be a fun problem that I can do. It might take a little while, but I get to draw a fun picture, and that's really all this is. If you understand polar coordinates, and you can make a t-table, then you can get through this problem, get the points, and not stress. Don't stress on this problem. Have fun with this problem. You get to draw a funky picture. So let's get started. Basically, remember that polar coordinates come in distance, angle. And with this equation, what's happening is we're changing the length of this distance based on the angle. So as we move around the circle and the angle changes, so does the distance away. So we may start in close and then get further away and come back. You know, it's going to do some different things. So the way to do this is it's like like those old movies where the submarines are playing cat and mouse in the deep ocean, and they got their little radar thing blipping around, and when you see a blip, that tells you the direction and the distance that that other object in the water is. So think of this as like you're using a radar screen. So here we go. We're going to make a big t-table. It's going to take a little time. It's really not that long. It didn't take me hardly any time at all to put this together, and since I've already done the work, we're just going to go with it here, and I'm going to show you what I've got. So here's my angle, and then -1 plus cosine theta. That's what we're using right there to calculate the distance of that radius. So for any given angle, we're going to go this radius. So all we have to do is take the angle, do -1 plus cosine 0, write the number down. I didn't do it for every one of these. It's nice that they give you, on this problem, they give you all every 15 degrees, but I don't think you need that much information to make a nice graph. What I would suggest is that you go every 30 degrees, get those, and if you feel like there's an area of the graph that needs some clarification, then by all means go back and do an in-between point here and there, but I don't think you need to do all these. This makes for a really large t-table. But by just doing every 30, I really didn't have to calculate that many. And there's some other things that I want you to notice here. Notice how these 0, small negative, half, 1, 1.5, you know, a little more than 1 3/4. Then it gets to -2, and then notice we get symmetry. And we just go right back down the same way we went up. Okay. The other thing I want you to notice, these are not positive numbers, which when you're doing polar coordinates and you get an R value that's negative, then you go in the opposite direction of the angle. It sounds complicated, but really it's just a matter of you go the other way. So instead of going that way, go the other way. And that's all we're going to do. So let's go ahead and plot these out, and I'll try to get it where you can kind of see what's going on here. But this one here is easy. When the angle is 0, then we go 0. So there's actually a dot right there. It's already black. I can't make it look any different. The other thing I want you to notice is all our numbers are between essentially 0, -2, then go back down to 0. So if we graph all this from here to here, if we call that 1 and we call that 2, the graph's going to be really tiny and might be harder to work with. So I think what I'm going to do is I'm going to call this 1 and this one here 2. All right, it's 1 2 3, 1 2 3, and then I think we'll just have to kind of work with it there. Okay, let's do the next one. The next one says when I'm at 30 degrees, when I'm looking at this angle, I go a radius of -0.13. Okay, well, 0.13 is just a little over 10%. So if my 1, right, and if it was a positive number, I'd go 10% of this distance, right? So, somewhere in here. but I'm actually going in the other direction because it's a negative number. So instead of going off in 30 degrees, I'm going to go in the opposite direction. Okay? The next one, 60, negative a half. So 60, but because I'm negative, I'm going to go a half, and halfway to 1 is right there. No, right here. Okay? All right, the next one, 90. I'm negative 1. So 90, I actually go all the way to 1. Remember, I'm going the opposite direction. Instead of going toward 90, I'm going the opposite direction. So you can see we're already kind of got a little curve going here. Let's, we really just need to do a few more. Remember, it's symmetrical, so we can then just kind of like work our way around the other way. So here we go. 150. No, 120 was our next stop. So at 120, we are negative 1.5, right? So we're going to go the opposite direction. We're going to go 1, and then we're going to go halfway to 2, which is right there. Then the next number, negative, or 150 degrees, and the number is negative 1.87, or just almost a little shy of 2. So we're going to follow this line, and we're going to go almost to 2. And then finally, at 180, we're at negative 2. So when we're looking at 180, we're going to go negative 2, and we're going to be back here. Okay, I'm going to go ahead and draw this part of it in. I'm going to start at 0. Remember, we had a point there. And we're going to just kind of curve around. And remember, this thing is symmetrical. So really, I just have to flip this up. And what I'm going to do is try to mirror my dots. Here. And then here, 1, 2, 3, 1, 2, 3. And then here, I'm in here. And then here, I'm about right there. And so now I just draw this other half. And it makes something called a cardioid. And that's really all there is to it. It's kind of a fun exercise. I don't think I needed to plot any more than I did. I think that was about the right number of angles to plot. And of course, you know, if you'd have done the first half and realized it was going to be symmetrical, you wouldn't have had to done all those. Actually, I don't think I calculated those. Once I realized it was symmetrical, I just wrote them in. So this one doesn't really take all that long. Relax when you get to this problem. Make a nice t-table. Know that it's going to make some kind of weird shape, and it's going to be kind of fun to discover what it is. And then get that problem right, and don't worry about it. This one's not too bad.